Hi everyone, in this video I'd like to go over method of sketching rational functions here, mainly focusing on asymptotes, vertical and horizontal asymptotes. But first thing we're going to do when we look at the rational function, we change it to standard form, because from the standard form we can easily read off the vertical and horizontal asymptotes, actually the horizontal asymptotes, and from there we can easily calculate the behavior around the horizontal asymptotes, which is what's number 2 I wrote here. We're going to look at the positive infinity. We'll do that again, positive infinity and negative infinity, which is going to the right or left. And if it has horizontal asymptotes, we're going to see if it is coming from above or below, and that's the sort of thing we want to figure out. Next thing is by looking at the vertical asymptotes right here, and we figure out how this end behavior around the vertical asymptote look like. So that's going to be something we can figure it out. At the end, by looking at this x-intercept and y-intercepts, and we can have additional information, and we can relatively locate the portions of graph fairly accurately. So these are usually the things that we go through. So the first example we're going to look at is this degree 2 polynomial divided by degree 2 polynomial. So degree of the numerator is greater than or equal to degree of the denominator, which is 2. So in that case, we're going to do this long division to rewrite this one such that this fractional part here, becomes the part such that the degree of the numerator here is smaller than degree of the denominator. Right now it's 2 and 2 is the same. So if you do the long division and this degree is the same, so the quotient here is going to be only a constant. So you're doing only one time in this division, then accidentally this -4 and -4 canceled, so we only have remainder 3. So let's put this thing together into standard form. So as a polynomial, the left hand side, which is the dividend, is equal to the divisor times the quotient. That's what we calculated up there, and the remainder here that came from this part right here. So this is an algebraic polynomial identity, and by dividing this divisor both sides, we can get a quotient form. So as you divide both sides, that divisor here appeared in the denominator of the left hand side, and this 2 appeared as a quotient, and this remainder that we calculated above appeared as a numerator of this standard form I call. And make sure you get this degree satisfied. The degree of a numerator now is less than the degree of a denominator. So I wrote down that standard form on this part right here. And first thing we're going to do, we're going to determine the end behavior of the horizontal asymptotes. That is, when you go to the right, to the positive infinity. When you go to the left, that's a negative infinity. What happens to this value? That's what we're going to figure it out. So let me first explain what happens to this denominator part. That's the part that's actually what's happening, because other parts here, 2 and 3, they're constants. This is the only part that's varying. So if you just look at the denominator part, which is copied here, because degree of this polynomial is even, as you can see, the end behavior of this polynomial as you go to the positive infinity or negative infinity, they all go to positive infinity and positive infinity. That's how this end behavior of even degree polynomial looks like when the coefficient here is 1 and here is positive, so therefore it looks like that. So we know what happens to the denominator part. This is always going to the positive infinity as x approaches positive infinity or negative infinity. So both cases, this 3 divided by x squared minus 2x plus 1 is going to approach, this part here is going to be approach 0, but from above. That's what this notation is about. We know it's approaching 0 because 3 is fixed and then x is going to infinity like that. But there's one more information we're putting in there, is that it's not only approaching on 0, it's approaching remaining in the positive. So if this is a positive number very close to 0, this whole quantity here is going to be 2 plus. Is it very close to 2, but it's slightly greater than 2, such as number 2.001, something like that. So this type of a number is an example of 2 plus. Number that is almost 2, but slightly greater than 2. So let me give you a picture. So what I mean by this 2 plus is that as you go to the right, and this is an example of the behavior towards the infinity, as you can see, the graph remains above here, above the line y equals 2, so it's remaining slightly greater than 2. Even if you go to the left infinity direction, that you can see the portion of graph here remains above the line y equals 2. So these are the y values. So that's something we can say by looking at this portion of the standard form. So that's why we're looking at the standard form, determine whether this remains positive or not. So that was horizontal asymptotes. Next thing we're going to look at is this vertical asymptotes. So the vertical asymptote is coming from the denominator of this polynomial, so we need to factor that part of the function. So when you factor the denominator, it turns out it's x minus 1 and x minus 1 are the linear factors, so we actually have multiple rows in the denominator. That's what is contributing to vertical asymptotes. So we only have actually one vertical asymptote, which is shown here. So the function is still written up here. Just let me review about the basic cases of y equals 1 over x to the n, which is this portion here. Especially when n is even, you remember the graph of this function around the vertical asymptotes here is both pointing upwards like this. And that's the interesting part of the even exponent thing here. So the case of odd exponent, which I forgot to write down here, so I'm going to put down an odd here. When it's odd, one side is pointing up and the other side is actually pointing down. So there's a difference between these two even power and odd power case. So what we're looking at up there is definitely an even case. So locally, turns out the graph of this function just around the vertical asymptotes x equals 1 is looking more like this. Sorry about that. Right, this is how the function looks like right here. Especially the denominator part is the where the vertical asymptote is coming from, and we want to figure out the behavior around x equals 1. We already know it's even case, but here what we're about to do is try to determine whether it's both pointing up or pointing down. So what we're looking at it here is you take that expression, you know the denominator is actually the same as this x minus 1 squared, so that's the responsible part. This is the part that's making things very extreme in the value. But we're interested in the behavior of this function value when x is very close to 1, not exactly 1. This is the wiggly symbol. It's kind of close to 1. So that part, we're going to leave it. But what happened to the numerator is that when x is very close to 1, is nicely predicted by actually plugging in x equals 1 in place of x instead of 1.1 or 0.9, those numbers. So you can just plug in that correctly predict especially the sign of these values. That's what I'm doing here. So x equals 1, this is the value we're interested in, and you plug it in there, and this value correctly predicts the sign, whether positive or negative, that is multiplied to this x minus 1 even power part. So when you simplify this part, turns out it's just 3. So 3 is a positive number, as you can see. So this one will be both pointing upwards like this. Pointing up like this. and that's what's sketched here as x approaches. So here, as x approaches 1, the behavior around the end behavior of the graph around the vertical asymptote x equals 1 is pointing upwards here. If this were instead a -3 instead of +3, and this will be a picture that's both pointing down like this around the vertical asymptote. So I sketch it here in this tiny picture. So the function has this horizontal asymptote 2 and vertical asymptotes 3, and that those are indicated here. Vertical asymptote 2 and vertical asymptote 1, horizontal asymptote 2. So the overall simplest behavior you can imagine using the information we have is this one. So we don't exactly know what happened in between those two parts, but knowing that what happened around x equals 1 or toward to the end of to the right infinity, toward the left of infinity, if we assume simplest thing is happening in between those things, and this is the reasonable picture to come up with. So that's our answer. But in calculus, we learn more about how to take care of the parts in the middle to and intelligently figure out where it goes up and down and things like that. But with what we know algebraically, just by looking at this information from the standard form, and this is reasonable to conclude, and the fact is that it actually looks like this.